Hi everyone, welcome back to Chemistry Universe. And we're doing amines, and this is video number 10, part 10 of amines. And this is part 4 of the chemical properties. The last one we did was the carbolamine reaction, and as I said, is a test for primary amines. This one is actually a test for all the three primary, secondary, and tertiary amines. One can distinguish which particular amine you have. Of course, provided you already know that it's an amine, and there are various ways of doing that. And we have a separate chapter called Practical Organic Chemistry where we will deal with all of that. So prima facie, the fact is that this particular reaction will help you understand how to distinguish between these three, and this is called the Hofmann Mustard Oil reaction. So let's get on to the video. All right, so here we have Hofmann Mustard Oil reaction and HNO₂. We'll also be doing reaction with HNO₂ in this. So this is the Hofmann Mustard Oil reaction. Now you don't get mustard oil, you'll get a compound that smells like mustard oil. So what happens is when alkyl amine, and I'm talking about primary amine, is heated with carbon disulfide and mercury chloride, alkyl isothiocyanate is formed which smells like mustard oil. So remember, look at the reactants. Alkyl amine, so it means primary amine. Otherwise, it would be dialkyl amine if it is secondary. So alkyl amine, so primary amine, is heated with carbon disulfide, that is CS2. Can you guess where this is going? The lone pair on N is going to attack the carbon, right? And the pi bond shifts to S. You're going to get something like this. And this will show intramolecular proton exchange. You get this. Now you have a second time intramolecular proton exchange. As I've already discussed this, we can have them as many times and we can make them go back and forth also, which is why they're all reversible. Now what happens is, since we have also added, this says and mercury chloride. Now what does this do? This mercury chloride helps release this H2S, because this HgCl2 will react with H2S, forming a black precipitate of, reddish red and black precipitate of HgS. And so this is the alkyl isothiocyanate, and you have the HgS precipitate and HCl, and this smells like mustard oil. And this is the mercuric sulfide, which is red and black. And that would be the precipitate, and you can also use that also as a test. And if it were a secondary amine, as I said, it's also important for us to understand what happens in a secondary amine. In secondary amine, you will get a reaction though. And after the first intramolecular proton exchange, there is nothing much happens because the nitrogen doesn't have any intramolecular proton exchange. So if you add HgCl2, nothing will happen. Whereas the tertiary amine itself will not react with CS2. And one can always find when a reaction is happening or not, because you can test whether the CS2 is being left behind the amines. You can do an amine test and check whether the amine is still left. If it is not left, it must have reacted. So this can be used as a test for primary amines, in fact, primary, secondary, and tertiary amines. Then we talk about reaction with HNO₂. Now we've already done this reaction of primary amines and secondary amines with HNO₂. We did this when we did the ARSN2, if you remember, ARSN1. We're talking about ARSN1, where a diazonium is formed. So you have an alkyl, you have a diazonium formed, a primary amine reacting with Na2HCl, which is basically HNO₂. It will form a diazonium salt, and that diazonium salt, if it is aliphatic amines, will directly go into alcohols. So this is that particular reaction. So you have this primary amine, you have an Na2HCl, remember temperature is between 0 to 5, you have a diazonium ion, water acts as a nucleophile, you'll get always an alcohol if it is aliphatic. Whereas if it is secondary, it will stop at N-nitrosoamine, and it is a yellow oily layer and it is carcinogenic. So when you see the bubbles, it is primary. When you don't see the bubble, you see the yellow oily layer, it is secondary. And this forms a tertiary amine, forms a water soluble oxide or a nitrite diazonium nitrite, trialkyl ammonium nitrite, which is water soluble. Whereas the tertiary will form an ionic compound, which will be a trialkyl nitrite, trialkyl ammonium nitrite, which is water soluble. And but there is one particular important thing that you need to understand, that even though we did say that primary amines end up becoming primary amines end up becoming alcohols, but doesn't happen with methylamine. Methylamine does not form methanol. It in fact forms an ether. It forms an ether because this is a good leaving group. And if you have a methylamine and this is converted to this, so what basically happens is that a part of it would become an alcohol, part of it would be still a diazonium ion, and this will attack this and this will go, and then the H plus will release and you will get a dimethyl ether. So this is the major product. And remember, we are not here to find out why something happens. We're interested in knowing, if why is available, it's great. Otherwise, we're just here to explain what actually happens. And that ends the video. Hofmann Mustard Oil reaction and reaction with HNO₂. So with that, we come to the end of this particular part. And I'll see you in the next one. Till then, have a great and wonderful day. And thank you for watching this.